So today's discussion will be about scalars and vectors. So what is scalars? That basically in physics and engineering we are interested in quantities that we can measure. Okay. So and these quantities can be classified into scalars and vectors. Basically, we can these are not the only categories. Okay, we have tensors and there are some other things also, but at least for this level we are interested in those physical quantities which can be categorized into scalars and vectors. Now what is a scalar? Scalars is with the help of standard unit system and a number we can measure some quantities. These quantities are basically scalars. For example, temperature. If we say now temperature of my room is 18 degrees Celsius, so to represent the temperature we needed a number that is 18 and degrees Celsius it is the unit. For all quantities it is not sufficient. Okay, there are quantities for which we require a direction along with number and unit. These quantities are called vector. For example, electric field, force. Okay, like uh, if you say that a force 20 Newton is being applied on a particle, then we can understand that a force which whose magnitude is 20 Newton is being applied on the particle, but in which direction? So to represent it fully or to measure it, to measure the quantity like these, we need to define the direction also, and such quantities are called vectors. So these are the definitions which are well known to you. Now we will talk about properties of vector. So geometrically, vectors are represented by array. This is basically geometric representation. Okay, this is the representation of a vector, say a. Now the length of the array represents the magnitude of the vector. The array points in the direction of the vector, but remember one thing, it does not mean whenever you have an array this actually represents an this represents a vector. Vector does not mean an array. This is an representation. This is a representation of vector basically. Okay, now how can we write a vector? We write vector, three ways are used. Number one, a with an bar, a with an arrow over it, and bold a if a vector is a. Now in I always write this actually. Some people, I have seen some people write these also, but I think it's quite hard to write this. Okay, and it's quite hard, not quite hard, but it's a bit more harder. Okay, a bit harder than these. And there is another important point that if you slide a vector, let's say we have this vector, and if you slide it without changing the length or the direction, then the vector remains the same. This vector and this vector are the same vector, because this is a very important point. Now for vectors there are two operations. Number one, vector addition, and number two, vector multiplication. So vector addition is defined by triangle rule or head to tail addition. So what is the procedure? The procedure is that say we have been asked to find a plus b. What we will do, we will represent a by an arrow. This is the arrow. Then we will place the tail of b. This is the tail and this is the tip. So tip and tail. So we will place the tail of b at the tip of a. Then the arrow that connects the tail of a to the uh, tip of b represents the addition of a and b. This is the definition of a plus b. Okay, so there is an equivalent construction which is very much well known to you, I think, that is vector parallelogram, vector addition using parallelogram. So as I have told that we can if we slide a vector without changing its length and direction, the vector remains the same. So we can say that these vector and these vector are the same, and then we can draw a parallelogram, and these diagonal of this parallelogram represents a plus b. Okay, now and in I think in your college level physics you have derived this equation that if p plus q equals to r, then magnitude of r equals to p square plus q square plus 2pq cos alpha whole to the power half, and the alpha is the angle between p and q, and tan theta, where theta is the angle between r and p, equals to q sine alpha divided by p plus q cos alpha.
Yes, sir.
Okay, so actually these formula will not be used that much in this course. We will use this, but not that much. But in college level, I think students solve quite a good number of problems using this formula.
Yes, sir. It was an important formula for that chapter. Apologies.
Okay, so remember one thing, what in some cases we do not understand that these are basically the same thing. Vector addition and vector parallelogram, these are basically the same thing. Okay, and now there are some properties of vector addition which you should learn well, because in exams there might be questions that which properties have been followed in this vector addition, in these calculations, or in this something like this. So you should understand what are the definitions of those properties, and what are the underlying what are the um, applications of those properties. Now first one, commutativity. So commutativity means order does not matter. Okay, if we are asked to calculate a plus b, then if we calculate it in this order or in this order, we will get the same result. Okay, this is called the property of commutativity. Remember, order does not if you can exchange the order, then it's commutative. Okay, now associativity, let's say we have been asked to calculate a plus b plus c. Now if we calculate b plus c first and then add a with them, we will get this result. And if we calculate a plus b first and then add c with it, then we will get the result. So actually in both way we can get the same thing. Okay, this property is known as associativity. That is, in case of addition of three vectors, it does not matter with which two starts with. Okay. And the third property is identity element for vector addition. So what is identity element? There is a unique identity element which is called null vector, and if you add the null vector with any vector, the vector remains unchanged. Okay, so what is the definition of null vector? Its magnitude is 0, direction is not well defined. So this is basically null vector. Now you can, I have seen that null vectors have been written using a bar on it. Some people write it without a bar on it, but I think it's not actually a that much important thing, and I prefer using without using bar, right? Writing that without using bar, but we do not need to use it, or that is null vector will be does not have that much use in this course, so we need there is no point of being worried about that. So this is identity element, and there are another element also which is called inverse element for vector addition. So what is inverse element? Inverse element is if a is a vector, minus a is the unique inverse element. If you add a with minus a, you will get a null vector. Okay, so this is called inverse element. These are the properties of vector addition. Now if you have any question, you can ask. So no question. Okay, now we will start vector multiplication. Now vector multiplication, vectors can be multiplied by scalars, and also it can be multiplied by vectors. So the multiplication between vectors is very much important for this course, but we will not discuss uh, vector multiplication in today's multiplication between vectors in today's class. We will discuss about multiplication of a vector by scalars. Let's say we have a vector a and c is a scalar. Now if you multiply a by c, then the magnitude become these, and the direction is the same. CA, that is CA and A have the same direction. So let's say C equals to 2, then if this is A, 2A will be double of it, the direction will be same. If C equals to half, A will be halved, the direction remains same. If C equals to minus 2, then the direction will be reversed, but the length will be double. Okay, now tell me one thing. CA and AC, are these same? That is, are they equal?
Sir, I guess it is equal.
Yes,
Yes, sir,
sir.
it's equal.
It is
Yes,
equal, sir.
it is
Yes,
equal.
sir, equal.
Equal. because if you, these are scalars, a number, right? So if we write 2 into a or a into 2, but you will see we use a standard writing style in all, everywhere in textbook, lecture notes, you will see these. People do not write this, and sometimes due to this some people think, is it commutative or not? But yes, it is commutative and nothing problem with these, but it's just not the standard format. That is it. Okay, so there is an identity element for scalar multiplication. So identity element, we have actually identity element for different kinds of operation, like vector addition. We had 0. If we add 0 with a vector a, the vector remains unchanged. For scalar multiplication, if you multiply any vector with 1, then you will get the same vector. That is why 1 is the identity element for scalar multiplication. Now, associativity law for scalar multiplication, there are some properties that we for scalar multiplication too, as we have seen for vector addition. So number 1, associativity law. Now what is associativity law? Associativity law is, let's say we want to calculate bc times a. Now if we calculate c times a first and then multiplied by it b, then we can derive, we can get the result. And if we calculate b times a first and then we multiply this thing by c, then we will get the result. So both these things give us the same thing. Okay, but it might, you might feel that these are quite obvious thing, but actually these are not quite obvious thing. Okay, I do not know in Tripoli there are much uses. Will there be any math courses in which you will learn group theory or group algebra? But I think CSA people learn that. Okay, or linear algebra at least. That is that should be a mandatory course for CSA people. So in linear algebra course, you will learn that these are not as obvious as you, some of you may think now. And actually when I was a student, I was thinking, okay, these are quite obvious things, what is the point of writing this? But there are points of writing. Okay, so since we are trying to give a short but formal, and as kind of we are trying to be rigorous, so we need to study these things. Okay, but it would have been better if I can say you the significance, why learning these properties is important. Now the next one, distributive law for vector addition. So distributive law means, say we want to calculate c times a plus b. If we calculate ca first and then cb, and if we then add them, then we can get the result. So this is called basically distributive law for vector addition. Remember that this is distributive law for vector addition, and that is. Now unit vector. What is unit vector? Unit vector is basically defines, say we have a vector a. Now if we divide vector a by the magnitude of of a, then we can get then we get an unit vector in the direction of a whose magnitude is 1. Let's say a represents a velocity and a equals to 5 meter per second. So, and we are, let's say these are the division of the velocity graph. That is, this is 1 unit, this is 1 unit, this is 1 unit, this is 1 unit. Let's say this is v equals to 4 meter per second. So this 1 unit is basically the unit vector. If you give an arrow here, this you can also call this unit vector. This is also a unit vector. You just need to put an arrow here. Remember one thing, magnitude of unit vector is always 1. So far we have discussed vectors without using coordinate system, and it makes complete sense. We do not need coordinate systems to deal with vectors, but the use of coordinate systems may make calculations very simpler. That is why we need to know how can we deal with vectors in Cartesian coordinates. Now, in Cartesian coordinate systems, the unit vectors along x, y, and z axis are given by I, j, and k, and you can decompose any vector, any 3D vector into its components like this. You can actually decompose any ND vector, that is n-dimensional vector, into its component. Now tell me one thing, if a 3D vector has 3 components, then what will be the number of components for a n-dimensional vector? How many components a n-dimensional vector has?
Or n number of components?
Yes, n number of components. Okay, so since at this level we are interested in only 2D and 3D vector. Okay, so if you can write any 3D vector like in this way, you can also write a vector A, um, a 2D vector A in this way. Okay, so now we will learn one of the important concepts, which is which you need to practice for exams, that is resolving vectors into components. Now let's say start with a 2D vector. Let's say we have a vector in xy plane and p is the vector. If you draw a perpendicular from this point on x-axis, and then and the angle between, let's say the angle between p and x is theta, then if theta is the angle, then this is the perpendicular, this is the base, and this is the hypotenuse. Then this length is p cos theta. And if this is p cos theta, this is p sin theta. How? If this is theta, this will be theta. If this is theta, this is perpendicular, this is base, and this is hypotenuse. So this length should be p sin theta. Now if theta equals 30 degree, px will be p cos 30 and py equals to p sin 30. Okay. Wait for a minute, please. Now tell me that if we have a force vector which makes an angle 60 degree with y axis, then what will be the value of fx and what will be the value of fy? Okay, tell me that. How can we calculate them if magnitude of f equals to 20 Newton? Hello.
Sir,
Yes, sir.
fx equal to 20 cos 150 degree,
Okay, good. And if
fy is 20 sin 150 degree.
good. So both the answer are correct. Now we will learn the general rule. মানে what we see in our in our previous classes that the angle is in most cases is in between 0 and 90, but it might not be the case. The rule is that say we have been say component of we want to calculate component of p vector along q. These two vector can be any vector. Component of p vector along q equals to magnitude of p times the anti-clockwise angle between p and q. Okay, you can use the clockwise angle. In that case, you just need to add a minus sign before the answer. Now, look here, x is this, and here we have force. So this is the angle between anti-clockwise angle between x and f, but this is the clockwise angle. Remember that. How do we know which angle is the anti-clockwise and which one is clockwise? We'll start from x on which we want to calculate the component. On which we want to calculate the component. We'll start from that vector and we will go to f. Okay, this is the anti-clockwise and this is the clockwise angle. So we will take the anti-clockwise angle to calculate the component. Now this is the way. Now there are some other ways also, like for example, as just Khalid said, that the fy equals to f sine 150 degree. That is the correct answer, but we can write it also f cos 60 degree, right? This is the vector, this makes an angle 60 degree with y, so we can write f cos 60 degree. You will see that this to give the same value. So in this way we can calculate the components. Now so this is resolving vectors into components in 2D. So we can also we can also resolve vectors into components in 3D. Let's say we have a vector r like this in 3D, which makes an angle phi with positive z-axis. So rz, component of r along z, will be r cos phi, and p is the projection of r. P is the projection of r onto xy plane. Okay, so how can we draw projection? We will draw a perpendicular from this point to xy plane, and then we will just add the origin to the tail of that perpendicular. So P is the projection of R in the xy plane, and the angle between P and X is theta. Let's say we have assumed this angle is represented by theta, and the angle between R and Z is represented by phi. Now Z and P is perpendicular to each other. Okay, so Z and P is perpendicular to each other. Can you tell me why? Why Z and P are perpendicular to each other?
Sir, it's because it's on the XY plane.
Yes, good. It's on the
And
XY plane. Any vector on XY plane is perpendicular to Z axis. Now, the component of P along X is P cos theta, and the component of P along Y is P sin theta. So what is the component of R along X? Look, P itself equals to R sin phi. If RZ equals to R cos phi, P equals to R sin phi. Okay, since these two are perpendicular, so component of R along X will be P times cos theta. Okay, and then component of Ry along Y will be sorry, R sin phi. It will be R sin phi cos theta. So in this way we can calculate components of a 3D vector using the magnitude of the vector and the angles. Okay, so please wait for another 1 minute. Okay, so actually in our exams we do not give questions to calculate the component of the 3D vectors usually, but if the question is given, I think you will be able to solve. Now there is a point that what I want to say, wait, let's say we have a vector which makes an angle of hello, yes,
Yes, sir.
yes, is there any question?
Yeah. Mine's not a question, but it's just a clarification.
Yes,
So there's something that I'm not acquainted with.
yes.
So can you at least make an highlight about how angle are presented on 3D? I'm not actually clear with it.
Okay, how angles are represented in 3D.
Yeah.
And there is another question, I think. Yes.
Sir, RX and RXY, RY both are same.
Oh, sorry. Will not be same. R sin phi, sine, this is Ry. Now, is the question by Riak. Okay, so let's say this is YZ plane. Okay, so this is Z axis and this is Y axis. So the angle between Z and R, this is phi. Now what is theta? So theta, if we can draw a perpendicular of R in XY plane which is not shown in this board. Okay, the x-axis will be in the perpendicular direction of this plane. So we can draw an xy plane. Okay. So if you draw an xy plane and if you draw the projection of r onto the xy plane, then the projection will be given by P, which is drawn like this. Now this P makes an angle theta with x. This is the definition of theta. I will come to your question, Tausif. But Riyak, did you get your answer?
Yeah, it's clear.
So, Tausiful Islam.
Sir, shouldn't Rx be R cos phi cos theta?
Let me check. Rx, no, because first of all, Px equals to P cos theta and Py equals to P sin theta. Okay, so these are the components of P. Now P is the sine component of R, because if Z is the cosine component of phi, then P should be the sine component. As like this, just I wanted to show you that. Let's say we have a vector with this, so this is a P vector, so which makes an angle (20° with y-axis. So now tell me what will be the component x.
Sir, it will be P sine 70°.
P sine 70°. No. Now let me explain why. So this is 20°. Okay. So you can draw a perpendicular, so this is 20°. Now if this is 20°, and since this is a right triangle, this is a perpendicular and this is a base, and this is hypotenuse, which is P. So let's say this will be the x component, Px. Now hypotenuse by base by
Oh, sorry, sir. It's cos actually. Sorry,
cos 20
I
degree.
thought. Yes,
So
sir.
Px equals to P cos 20°. So wait a second, have I made any mistake? These will be
Sir,
perpendicular. This will be sine 20°. This is theta, this is perpendicular, this is base, this is sine 20°. So Px equals to P sine 20°. And here this is theta, so this is perpendicular and this is base, which is Py. So Py, base divided by hypotenuse, equals to cos 20°. From here we can write P cos 20°. Okay, so just remember one thing, that this is the actually very much general formula for finding component that the board. Yes, component of P vector along Q equals to P times the anti-clockwise angle between P and Q, cosine of the angle, cosine of the anti-clockwise angle between P and Q. So if you follow this, then in this way the component of P along Y is P cos 20, and the angle Y and X are perpendicular, right? So you can easily say that Px equals to P sine 20. Okay. So this is the thing. Now you have seen that we can calculate, we can do it in this way: px equals to p sine 20 degree, py equals to p cos 20 degree. We can also calculate it in another way. If it's 20 degree, it is 70 degree. Then px equals to p cos 70 degree and py equals to p sine 70 degree. So px equals to p sine 20 degree, and which is equals to p cos 70 degree. We can also have this line from this line using trigonometry. Now, what is the point of finding components, or what is the point of learning that how can we calculate components in using two formulas? The point is that we will derive some expressions, and in your assignments you will also derive some expressions where you might need to keep cos or you might need to keep sine. So the thing you will be asked in the question, you will keep that in your derivation. So, and that is why we need to know how can we do it in both way. And I hope everyone knows that how can we write p sine 20 degree equals to p cos 70 degree. If anybody have question about this, you can also ask this. You can check this by calculator, but there is a trigonometric rule for these also.
Will cos 90 minus 20.
Yes. If anybody do not understand how can we write this using trigonometry, you can ask. Everyone understand. Now it's there the you need to do two things now. For one, what will be the component of B along A? How can we calculate it? Component of B along A.
P cos
B cos
75 degrees.
B cos 75 degree. Is there any more answer? So
Sir, B sine 90 minus 75.
B sine 90 minus,
75.
so basically B sine 15 degree.
Yes, sir.
So now I will follow my rules and will check which answer is correct. So the rule is that we will first assume that both the vectors is in the same direction. Now look, we have to calculate component of one vector along another vector. So there are two things, that of and along. So of B along A. So the along will remain same. We will just then so these were our along component of B along A. So these will remain same, and B will be initially, we will assume that this is in this position. Then we will rotate it anti-clockwise. We will rotate sorry, B, and we will rotate it anti-clockwise and we will reach its given position. So if you rotate it clockwise, you can also do it. If you rotate it clockwise, you can get the given position of B. Also, if you rotate it in this way, which is equals to this angle, if it's 75, and this angle will be what will be the value of angle if it's 75?
Sir, 360 minus 75.
That is actually I'm asking what is the value. 285.
285.
Oh.
Yeah.
So 285. In my formula, or in my procedure, the component of B along A equals to B cos 285. So B cos 285 equals to what? This is equals to B times, I think, 0.25 something. So if you take cos 75, these are the same thing. Okay. Now, if the angle is, instead of 75, if the angle is 120 degree, then what will happen? So then this angle will be B cos 240 degree. So what is the value of cos 240? Minus 0.5.
So minus half.
And cos 120, this is also minus.
Minus half. Yeah.
So in that case, the result will also remain the same. And somebody said B sine 15 degree. Yes, it will also give the same answer. Now, if we take the clockwise angle, then what would happen? BA B cos 75 degree. So cos 75 so the answer remains the same, 0.25. So this is all about calculating components of vectors in 2D. Okay, so this is I think this is the most used concept in this course. You have to repeatedly find out components of vector in different chapters, in Newton's laws of motion, in 2D motion, 3D motion, in rotational motion. For solving problems, for understanding theories, you will repeatedly see that we are calculating components of vector again and again. So now the class is end. Now it's up to you. So if is there any question?
sum up করবেন?
Yes. So there is a summary. I need to do a summary. Okay. So আজকের ক্লাসে Riak, are you hearing?
Yes, sir.
Okay.
I'm getting you.
So I am giving a Bangla summary. This will not actually be a Bangla summary. This will be a kind of a mix up. So I hope you have understand the class contents, right?
Yeah. No
Okay,
problem.
okay. তো আজকের ক্লাসে আমরা যেটা দেখছি সেটা হচ্ছে ভেক্টরের ডেফিনেশন কি, স্কেলারের ডেফিনেশন কি, দেন হচ্ছে ভেক্টরের প্রপার্টিগুলি কি কি, সেই প্রপার্টি ডেফিনেশনগুলি কি কি। তো এগুলি মানে ম্যাথমেটিক্যাল ডেফিনেশন, এগুলির কিছু কয়েকটা প্রপার্টি আছে যেগুলি প্রুফ করা যায়। বাট সিন্স তোমাদের জন্য আসলে প্রপার্টি জানাটাই ইম্পর্টেন্ট, এবং কোন কোন ক্ষেত্রে এই প্রপার্টিগুলি মানে তোমরা একটা অপারেশন দেখে বলতে পারা যে এই প্রপার্টিটা ইউজ করা হয়েছে কি হয় নাই, সেইটাই হচ্ছে তোমাদের জন্য নেসেসারি থিংস। তো এটা আসলে খুব একটা মানে ইয়ে হবে না, মানে খুব বেশি যে ফোকাস করা লাগবে এই টপিকগুলির উপর, ওই যে শুরুর দিকে প্রপার্টিগুলির উপর তা না, বাট জানা দরকার যে কোনটা কোন প্রপার্টি। অ্যান্ড দেন উই টকড অ্যাবাউট ইউনিট ভেক্টরস, যেটা হচ্ছে তোমার একটা ভেক্টরের দিকে মানে একটা ভেক্টর যদি এ থাকে তার দিকে ইউনিট ম্যাগনিটিউডের একটা ভেক্টর ডিনোট করে সেম ডিরেকশনে। দেন উই টকড অ্যাবাউট ভেক্টরস ইন কার্টেসিয়ান কোঅর্ডিনেটস। তো একটা 3D ভেক্টরের 3টা কম্পোনেন্ট থাকবে, আর হচ্ছে একটা n ডাইমেনশনাল ভেক্টরে nটা কম্পোনেন্ট থাকবে, একটা 2D ভেক্টরে 2টা কম্পোনেন্ট থাকবে। তো এখন কথা হচ্ছে যে এই কম্পোনেন্টগুলি কিভাবে বের করব। কম্পোনেন্ট তো বের করব আমরা যেটা দেখলাম যে ধরো একটা ভেক্টর আছে কিউ আর একটা ভেক্টর আছে পি, বা কিংবা এটাই ধরো যে একটা এ ভেক্টর আছে আর একটা হচ্ছে বি ভেক্টর আছে যাদের মধ্যে অ্যাঙ্গেল হচ্ছে 75 ডিগ্রি। ফর এক্সাম্পল আমরা বি এর উপর এ এর কম্পোনেন্ট বের করতে চাই, আমরা যেটা করব বি টাইমস বি এর ম্যাগনিটিউড, সরি এ টাইমস, হ্যাঁ এ এর ম্যাগনিটিউড টাইমস তোমার কোসাইন অফ দ্য অ্যান্টি ক্লকওয়াইজ অ্যাঙ্গেল বিটুইন এ অ্যান্ড বি। এখন আমি যেটা দেখছি যে আমাদের স্টুডেন্টরা অনেকেই অ্যান্টি ক্লকওয়াইজ ক্লকওয়াইজ আসলে মানে আমি যেরকম ভাবে করি ওরা নিজেদের মতন করে করে। হ্যাঁ, কেউ কেউ হচ্ছে মানে একই এক্সাম স্ক্রিপ্টের মধ্যে ক্লকওয়াইজ অ্যান্টি ক্লকওয়াইজ দুই রকমের অ্যাঙ্গেল ইউজ করে কম্পোনেন্ট বের করছে নিজেদের মতন করে, তাতে তার কোনো সমস্যা হয়নি। তো এরকম যদি কেউ পারো তাতে তো কোনো প্রবলেম নাই। সো এটা হচ্ছে আপ টু ইউ, তোমরা কম্পোনেন্টটা কিভাবে বের করবে। তোমরা দেখলা যে আমরা চাইলে sin75ও লিখতে পারি, cos15ও লিখতে পারি। So this is up to you how you will write the formula. It's তোমার যেটা কনভেনিয়েন্ট মনে হয়, বাট আমাদের both form, to know both form is important because in exams we may be asked to calculate some forms, or in assignments, or we need to calculate or derive some forms to understand those. We need to know how can we write cos phi equals to sin 90 degree minus phi. Okay, so 2D তে তো রিজলভিং বললাম শেষের দিকে, আচ্ছা শুরু করছি, এরপরে তোমার 3D টাও বলছি। হ্যাঁ, 3D তে হচ্ছে তোমার একটা ভেক্টর যদি r থাকে তার z এক্সিস এর অ্যালং z এক্সিস তার কম্পোনেন্টটা হবে r cos phi, যদি r আর z এক্সিস এর মধ্যে অ্যাঙ্গেলটা হয় phi। এখন r এর একটা প্রজেকশন যদি হয় xy প্লেনে p ভেক্টর, তাহলে এই p ভেক্টরটা তোমার যদি x এক্সিস এর সাথে থিটা অ্যাঙ্গেল ফর্ম করে, দেন অ্যালং x এক্সিস কম্পোনেন্ট অফ r ইজ r sin phi cos theta, এবং অ্যালং y এক্সিস কম্পোনেন্টটা হচ্ছে যে r sin phi sin theta। এইটা হচ্ছে তোমার 3D তে রিজলভিং। তো 3D তে রিজলভিং আসলে আমাদের খুব একটা লাগে না, মানে কিছু ক্ষেত্রে হয়তো লাগতে পারে বাট খুব কম। তো এই হলো আমাদের কম্পোনেন্টের রিজলভিং। নাও লেট মি আস্ক ইউ ওয়ান থিং, সাপোজ we have a vector. So I just finished summarizing things, and I just now I will give the last classwork. Okay, so let's say we have a vector r, and these are the three components. Okay, so if these are the three components, can we find out the magnitude of the projection of r onto xy plane and the angle theta, which is the angle between p and x-axis?
Yes, sir.
How?
Yes,
Sir,
sir. P will be just x and y. I mean, we can ignore the z part.
Yes, p will be xi, and this will be the vector form, and the magnitude will be x square plus y square whole to the power half, and theta equals to tan inverse y by x. Okay, good. So our class is done. Now attendance. So let me start. Is there any question?